Now, okay, just very quickly, what's energy? All right. Energy is actually the ability to do work. So, living things need energy to stay alive, right? And then non-living things also need energy in order to be operated. Okay. So need to understand what is the meaning of work. Okay, I think it's better to write it this way. Okay. All right. So have you done this topic already, Jocelyn?
Yeah.
So you completed the whole topic, huh? Good. So just quickly recap a bit lah. Since you said that you're studying for your exam, right? Exam is next term. So what is work? So we say that work is actually done when an object is moving after a force is applied. Okay, and then this object must move in the direction of the force. So therefore, the conditions is stated here. Conditions for work to be done, there is a force acting on an object. So there must be a force present. This object must move, and it must move in the direction of the force. Okay, so how much work is done really depends on the size of the force applied, as well as the distance moved in the direction of the force, right? So you know the formula already, right? Work done equals to force times distance. Okay. What's the relation between energy and work? Right. So when work is done, energy is actually transferred. Okay. The more work we do, the more energy that is being transferred. All right. So this part here important. Okay. In a system, in a closed system, okay, the energy, the total amount of energy, total energy is the same. Okay. No matter where you are in that process, the entire process. So this is what we know as what we know as energy is being conserved. Okay, you only need to understand this part. Okay, energy is conserved. Okay, we assume that there are no other factors coming in play lah. So the internal system, okay, total amount of energy before or after must be exactly the same. It's just converted from one form to another. Okay, because we know very well that energy, cannot be created or destroyed. Yep, it's only changing from one form to another. Now, main sources of energy, need to know this. Okay, you have coal, oil, you have natural gas. So these are actually formed from the, dead plants and animals that lived millions of years ago. Fossil fuels are non-renewable. Once they are used up, they are gone forever. Okay. Then we have renewable sources of energy. This you can actually find inside your textbook also, correct? Yeah, so all this can be found. Hydroelectric, okay, and then solar energy. These are the sources. These are the various sources, yeah. So you are quite familiar with all this, isn't it? So I don't have to go through in detail one by one,
Yeah.
okay? Otherwise you'll be so bored also. So what are the environmental impacts of energy sources? Okay, when we use energy, all right, when we need the energy in our lives, we actually also created a lot of issue. For example, let's say we use fossil fuel to produce the energy. We need to burn it. When we burn fossil fuels, there are gases like carbon monoxide, okay, carbon dioxide also comes out, okay, and then there are soot and particles. Now, so it's just not only this carbon monoxide that's harmful, okay? Carbon monoxide can actually lead to death, all right? There's also carbon dioxide produced. And then this actually can lead to global warming. All right? Okay. We don't say carbon dioxide is actually a form of air pollution, because carbon dioxide exists all the time. Correct or not? Even when we breathe out carbon dioxide. We cannot say that we pollute the air, right? So that's why you notice that it's not being shown here. But I want to tell you that when we use energy sources, let's say we burn fuels, okay, it produces carbon dioxide. This is a special thing. Carbon dioxide is not an air pollutant. The problem it brings is actually global warming because it traps a lot of heat in the air. Yeah, and then we feel very hot. All right. So carbon monoxide leads to poisoning, okay, and it can cause death. Then biofuels also cause air pollution, not just fossil fuel, biofuels as well when they are burned, okay, but then it is a lot lesser. And then impact on land and living things, okay, these are all the various problems that you can actually face, okay, like deforestation. Then when you want to build hydroelectric dams, then animals and people are supposed to move to another place. Hi, Ezekiel. Wind turbines contribute to noise pollution, okay? Wind turbines can kill birds, right? Because the turbines are always moving. So if the birds fly past, it can actually get hurt or even die. Hi, Ezekiel. Are you here? Both of you still cannot turn on camera, huh? Ezekiel,
Hello?
can turn on camera? Cannot.
No, I still don't have.
Still don't have. Okay, Ezekiel, actually we are on this topic on energy. So I actually went through some notes. Okay, I went through some notes with Jocelyn, okay, about energy. Jocelyn, you don't mind, I quickly go through with Ezekiel, okay? You can go for a toilet break if you need to, Jocelyn. Okay, Ezekiel, are you here with me? So let's look at this brief recap. All right, because you should have already watched the video right in the portal and then do your own revision, finish up the worksheet also. Okay, energy, we define it as the ability to do work. Okay, so both living and non-living things actually need energy to function. Now, what is done when a force moves an object in the direction of the force applied? Definition of work. Yeah. Some conditions, okay, to be satisfied for work to be done. There is a force acting on an object. The object moves, okay, and the object must move in the direction of the force. Clear on this so far? How much work is done really depends on how much force is applied and then the distance that is moved by the object in the direction of the force. SI unit in the joules. Then what is the relationship between energy and work? When work is done, energy is transferred from one thing, okay, or to another. Yeah. So the more work we do, the more energy that is being transferred. Energy conservation, okay, we cannot actually create or destroy energy. We only have it change from one form to another. Okay, this is known as conservation of energy. Total energy before and after the change is exactly the same. All right, so it tells us that amount of energy has been conserved. Sources of energy. Ezekiel, have you already done this chapter in school? Ezekiel?
Yeah.
You have done, huh? But you cannot recall everything, right?
Not everything.
Can. So do you know the sources of energy? Yeah, so these are the sources of energy. Yeah?
Yeah.
The main ones are coal, oil, and natural gas. Okay, and then these are the fossil fuels, right? Formed from the dead plants and animals that lived millions of years ago. We call them non-renewable. Why? Because once we use them up, it's very hard for us to get the same amount or to get that fossil fuel in our lifetime because we don't live millions of years. Yep. So each of us average lifespan maybe 60 to 70 years old only, right? So we will not be able to have new fossil fuels forming. Okay, so they are non-renewable. Once they are used up, they can't come back to us. Okay, however, all right, we know that there are renewable sources of energy in our lives also, like we can use hydroelectric. Are you familiar with all these energies, Ezekiel?
Yeah, most of it.
Sure not. Most of it, huh? So hydroelectric is actually the electricity that's produced from moving water. Okay, so water from behind a dam flows down pipes, okay, and turns the water turbines that will turn generators, okay, that's going to change the kinetic energy into electrical energy. Then there's solar energy also, energy from the sun. Okay, so solar energy is used to heat water, is used to cook, is used to generate electricity. Then you have wind energy, all right? Wind turbines, I think it's not so foreign to you because in P6, you would have already gone through most of them. Okay, wind energy, okay, then tidal energy, all right, and then geothermal energy, as well as biomass. Okay, biomass refer to plant and animal materials. Okay, something that's organic. So these are renewable sources of energy. Okay, now the impact, environmental impact of energy sources. Okay, they create air pollution because they produce harmful gases like carbon monoxide. Carbon monoxide can lead to death. Okay, there's also a lot of soot that's produced. And if we breathe it, it gets stuck in the lungs, right? So it can actually lead to lung problems. Okay, biofuels also cause the air pollution, but much less than fossil fuel. So I was telling Jocelyn as well, okay, when we burn fossil fuel, carbon dioxide is produced, and in fact, quite a lot of it. Why is carbon dioxide a problem? Now, it doesn't lead to air pollution. Carbon dioxide is already present in our atmosphere. Human beings and living things, the other living things, breathe out carbon dioxide. We are not polluting the environment. Okay, but when we burn fossil fuel, there's so much of the carbon dioxide that's generated or given out, right? Okay, carbon dioxide traps a lot of heat. Okay, it traps a lot of heat. That's why it can lead to global warming. Clear, Ezekiel? You can just give me thumbs. Okay.
Yeah.
Yeah. Okay, good. Okay, so what about the impact on land? Because we want to build hydroelectric dams, for example. Okay, so the habitat of animals affected, human also need to, shift from one place to another. We also clear forests to produce biofuel that leads to deforestation, and it can lead to, again, loss of the habitat of the animals. Okay, then if let's say we were to burn, all right, the trees that were removed, it leads to air pollution, global warming as well. Okay, then wind turbines, just now I already mentioned. Okay, it causes noise pollution. It can also sometimes lead to the death of birds. Okay, now let's see. Let's go on to the worksheet now. Just to check, Ezekiel, did you do the worksheet? Ezekiel, you did the worksheet already?
No.
Okay, then let's do it together now, Ken. I'm going to ask you to answer some questions and then Jocelyn will answer some of them, Ken.
Okay.
Can you see my PowerPoint?
Mm-hmm.
Okay. Now, so I need you to maybe take a screenshot of this one. Okay, renewable and non-renewable energy sources. All right. Yeah. And then